Hi, I'm Ahmed Daud, and in this session we are going to start a case study to practice logistic regression. So this case study will have two parts, uh, like we are having in the last case studies. The one part will be regarding the data analysis, which will be EDA, and the second part will be model building. In the model building, there will be again two parts. One part is model training and the selection of best parameter values for the logistic regressor, and second part of model building will be models performance evaluating of the classifier. Okay, so as this is the first case study in which we have categorical target variable, so that's why I will put a lot of discussion on the EDA part also. Okay, so what actually the case is here? The case is there is some bank, and bank want to minimize its loss. Bank needs a decision rule regarding whom to approve the loan or and whom not to. An applicant's demographic and socioeconomic profiles are considered by loan managers before a decision is taken regarding his or her loan application. So in this dataset, each entry represents a person who takes credit from a bank. Each person is classified as a good or bad credit risk according to the set of attributes. Okay, so we already have data set. Like here we have data set, and in which we have this as a target column, and already each sample is classified that this person is at risk or not. Okay, this is classification, or this labeling is done manually and by the bank's team, and they have this data set. Now we will train such a model, we will build such a model that can in which they have not to do manually check all the attributes of the columns or the attributes of some person. Just they have to pass the value to the model, and model will classify that this person is at risk or not. Okay, whenever new applications or new application comes to a loan manager, he will pass the value to that model, and model will predict that this person is at risk or not. And by taking the help from the prediction from the model, the manager can approve the loan, and can decide whether he has to approve the loan or not. Okay, each sample is representing a person who takes credit from the bank. Let's say this is the first sample, a person who has age 67 years. He is a male, job skilled, housing owned, saving account title is little, type of saving account is little, checking account type is also little, credit amount 1169 Deutsche Mark, which is German currency. So 1169 Deutsche Mark here, this particular person has credited in 6 months. Okay, and this person is not at risk. For what purpose he has credited that amount? Uh, for the purpose of buying radio or TV. Okay, so here this person is not at risk. In this way, there are a lot of data set about, if we will see here, about 1000 persons, that are 1000 persons uh, who, and against each person there is a risk value that this person is at risk or not. Okay, if the risk value is 0, then person is not at risk. If the risk value is 1, then this particular person is at risk. Okay, or risk mean that this person will default. Okay, so what our model will do, as this data set is uh, labeled by some bank's team manually. So our model will learn the patterns from this data set, that which type of customers usually uh, have risk value 0 and which type of customers have usually risk value is equal to 1. Our model will learn that patterns, and then our model will be able to classify the given person the as a risk is equal to 0 or not. Okay, so this type of data set we will have in this case study, and objective is to build the model. Okay, and here there is not mentioned objective regarding the analysis of our data, uh, but we will do analysis so that you will whenever you will find some another type of problem statement, you will be it will be easy for you to do some data analysis on the problem statements on the on the data sets. Okay, so uh, here the most important part is to whenever you will face some problem in some field in some project, when you are doing some real-time project, so the first and very important part is to understand the domain knowledge. As this is just a practice problem, very precise problem statement is here, so there is no need to go in a lot of detail of that problem. But whenever you are doing some real-time project, which attribute you are not getting the fully understanding of that attribute, you are have some confusion with some columns, with some categories, you can refer to your team, other team who is responsible to collect the data. You can ask to that team that what this attribute, this category is representing here. Okay, and then you can go back and do the analysis and do the uh, processing, do the model building, the other stuff. Okay, so keep in mind, I have repeated multiple times, domain knowledge always have a lot of importance. Okay, so as I told, this code will have two major parts. Okay, so before going to start the EDA, we will first understand our data, what type of data we have, how many columns in that, what type of the columns, how many null values in our data set, and what type of shape our data set has, and we will import some important libraries here, and then we will continue our process. So first of all, like in the last case study of linear regression, we have imported an extension NB-BLAG just to make our Python code more structured. Okay, it will automatically uh, structure your data, sorry, your code. Then here import warnings to ignore the warnings, important libraries, pandas, numpy, train test applet, matplotlib, seaborn. Then here setting the options regarding pandas, logistic regression, all the sklearn.metrics are the measures that we have studied in the last sessions regarding the classifiers. Then the binarize, and binarize to uh, whenever we have to set a different threshold uh, with respect to default threshold, like usually default threshold we were using, or our model class of sklearn have built in 0.5, and if we want to see some our prediction with respect to some different threshold, we can use a binarize method to see the prediction with respect to different thresholds. SFS sequential feature selector to select the some important features, and grid search CV. Um, this will be maybe it's first time for you to have a look on the grid search CV. In the coming modules, we will do uh, in detail regarding grid search CV hyperparameter tunings. But for now, we will not go in the deep detail of that grid search CV. And actually, for what purpose we will use it? we have to select some best parameter values of our logistic regression class. So that for that purpose, we will use this, and I will uh, discuss when we will reach to that part of model building. So first of all, I will import that libraries, and then this is the German credit.csv file. I am reading by using pandas, and here we have this data set. It has 1000 rows, 10 columns, and when we will print the info, here you can see all the columns have 1000 rows. We have 1000 rows. Our columns have here 1000 no-null rows. So there is no null value in our data set. Our data set is already processed, so there is no need to do cleaning part or imputing the null values. So here there are 3 and 4. 4 columns have integer data types and other 6 columns have object data types. But here this column is a target column, which is risk, and it also has two categories, 0 and 1. Okay, so it's also binary column, so this will be also considered as a uh, categorical column, or you can say object column. So overall we can say we have just 3 continuous variables in our data set: age, credit amount, duration, and other 7 columns are categorical columns. Okay, from here you can see age has 53 unique values, uh, duration has 33, credit amount has 921. So these are continuous variable, any value can come here, and all the other variables have some limited categories. And among all of them categorical columns, purpose column has 8 categories. Okay, so if we will see the summary of our continuous variable, age, credit amount, and duration by using the describe function. Here you can see age has 35 mean and its median is 33, and you can see that mean is greater than the median. The data set can be say here it's a little bit right skewed. There is some more variation on the right side, and from here you can also see that in the last quartile, from 42 to 75, there is a difference of about 33, but here the difference between the range of fourth quartile is 33, and the range of this third quartile is just a 9. Okay, so data is the values in the age column are right skewed. Now credit amount also have mean 3200, and its median is 2300. Again, mean is greater than median, so it's right skewed also. And from here you can also see in the last quartile there is a wide range here also, from 3900 to 18,000 in the fourth quartile, but in the rest of quartiles there is low ranges. So again credit amount is right skewed. Duration has mean 20. So on average, you can say the person, each customer has duration 20 months. Okay, so each person has credited amount for 20 months. So here median is 18. It is near to the uh, our mean, but again it is right skewed because mean is greater, and from the fourth quarter you can analyze. You will get more precise idea regarding the skewness of these continuous variable when we will have a look on univariate analysis. Okay, now we can discuss our categorical columns. We have 7 categorical columns here, and one by one by using values count Okay, here we will see the frequency of different categories in each column. So male has frequency 690 and female are only 310. So there are about, you can say, 70% customers here are male and 30% are female in our data set. Here in the job category, there are three categories here. Okay, and out of these three categories, skilled category is the max, has max frequency. Okay, or in other words, you can say most of the people, most of the persons belong to category of job skilled. Okay, so here, if I will show you the description of the columns. So in the case of job, there are four categories: unskilled and no resident, unskilled and resident, skilled, highly skilled. But you have seen here, we are having just three categories. Okay, there is no any uh, value regarding, no any category, no any sample belong to the category unskilled and resident. Okay, so these three in the data description, data description is saying that there are four categories in job, but actually data is saying that there is are three categories. Okay, three categories in housing, and most frequency is, or most of the people have their own houses. Saving account, most of the people have for their account type of saving account is little. And again, in the case of checking count, most of people belong to the type of moderate. And overall, if you will see here, most of the people belong to little and moderate categories in both saving accounts and checking accounts. Okay, here in the purpose, a lot of people has credited amount for the purpose of buying car, then for the radio, TV, and less people have a purpose of domestic appliances, repairs, and vacations. And others categories means uh, these 12 people belong to the category who has credited amount for the vacation or for other purpose that are not listed here. There are two categories in our risk column. Risk is equal to 0, that this person is not at risk, and risk is equal to 1, that this particular person is at risk. uh, Person is at risk means will default, and the person is not at risk means will not default. And there is just 30% of the people or persons belong to the category of default, and 700 customers, 700 persons belong to the category of not default. Okay, and here you can see that our data set is unbalanced. Okay, a lot of categories, a lot of person uh, belong to the not default, and less number of people, about 30%, belong to the one category. Here keep in mind, when we have unbalanced data, the unbalanced data that can be due to two causes. There can be two reasons here. One reason is that actually the distribution of the data is actually uh, unbalanced. Okay, like overall, in overall cases, we can say there is always less number of people who default, and there are more people that as compared to the default people who usually not default. On the basis of that reason, usually banks are working. Okay, so you can see here the distribution, the unbalanced data set can be due to distribution, and unbalanced data set can be due to some other reason, that the distribution is balanced. But when they have collected the data, the people who belong to or who has responsibility regarding the collection of data, so they have collected data, more samples regarding to the zero category and less samples regarding to one category. Okay, So this can also be the reason. But here the reason is, according to me, is according to the imbalanced distribution. Here we have imbalanced values in that column. Okay, usually most of the people uh, usually belong to the not default category, and less number of people usually belong to the one category. Okay, by conceptual way you can understand. Okay, so now we will have a look on the univariate analysis.